is with great pleasure that I introduce our distinguished speaker for today's event. Jaidev is currently a Director of Technology at Gramener, where he works on technologies which make generation and consumption of data-driven insights easy. He has a decade of experience in machine learning and related software development. He's a regular contributor to the FOSS ecosystem. Please join me in welcoming Jaidev Deshpande.
Thank you. So I was speaking to Akshay yesterday, and he said probably should not expect a full house. And therefore, I am clearly not as well prepared as I should be. So I'll take it up with him later. This workshop is intended to be fairly interactive. How many of you have laptops which are connected to internet? Okay, a few of us. And those of you who don't, feel free to share laptops with others. And in any case, what we're going to do is, the good thing about data visualization is that pretty much everybody understands them very easily. This workshop isn't really about the code of it. It's not about being able to generate things quickly or so on. You have various tools to make that happen. We will be using Matplotlib, but that's just one tool. The workshop is actually about what we call the grammar of graphics, which is a general underlying taxonomy, or as the name suggests, a grammar for communicating design and communicating visuals. Right? That's what this is about. So we are just going to build things as we go along for the next hour, hour and a half, and so on. Feel free to occupy both the front rooms are pretty empty, so you can go at the back. Feel free to come and occupy the front rows.
Because you are trying hands-on, right?
Alright, so the grammar of graphics is basically a pyramid, and the lowest layer of it is, can you take a guess what the base layer of the grammar of graphics is?
Data?
Data, exactly. What would you like to visualize? Is there a data set in particular that you would like to tackle?
Elections.
Elections, great. Stocks, yes. House prices. Okay, where? It's Delhi, right? And Delhi should be a little more than that. Alright, elections, stocks. Interesting, okay. That is slightly more relevant than even house prices.
Air pollution.
Air pollution, great.
Election.
Preaching to the choir. Piyush is here. He works with India Today's data journalism team. Alright, let's take a look. So, what the United? We did have elections in 2019.
We have 19 India.
Oh, did they have elections at the same year? Alright, let's take something very simple first. We have a table here, right? And just because we have a table, the first instinct usually is to jump to visualizing the table. Bad. In most cases, what usually happens is that tabular data is actually a good way of representing, right? Because it allows the user subtype. I can simply sort by which party got the least votes, right? There is the Desh Janat party actually, we do a lot of work on elections at work, and this particular party has been interesting for many reasons. So has anybody heard of them, by the way? The least successful party of all time in India. they not only do they lose back packages. And it's like, most of these other parties are also familiar because they are one of them. They're among the least successful parties, but this Jangat party, can you guess why? It's, by the way, they are not an unknown party in specific regions. So the reason we found out, yes, please. Yes, in a sense, and there is honesty and there is abstinence. These people they do not give tickets to people who are non-vegetarians. Yeah. They do not give tickets to people who don't consume alcohol. Don't consume. Actually, they lose, right? So if you want to build a party where, and again, why this party keeps popping up is that they are in contest elections and everything, but they've never won anything. And you look at their manifesto, so they want to turn the entire country into Muslim and things like that. Anyhow, so as I was saying, there is simply a very good way to visualize data is simply through tables and of course. How do you know when to stop showing tables and show them visuals instead? What do you think should be the first heuristic of that? I have a table and people are perfectly fine with tables as long as columns can be sorted, right? Or in fact, in Excel you have features like conditional formatting of data and you can quickly see the highest value cells in darker colors and the others in light colors. You have star lines and things like that. Right? So tables are perfectly fine. When do you exactly too wide and too dead? Yes.
I think when we have filtered out the exact data we need, we just want to make it look very nice. Then we would like to have visualization. Because we have the exact data we want to show.
Right.
And we don't want to clutter the visualization so much that we cannot really see this kind of. So I think after filtering, it's a good idea.
Okay. You're on the right track, except what he said is slightly, it's more of the first heuristic in the sense, if you have to scroll, don't use it. If you have to scroll either horizontally or vertically, that's when you stop using it, right? For a given view, for a given screen size. And you can't see things like, let's just zoom out, that just messes data up. So stick to a particular resolution and start doing it. Let's take a look. Now, the good thing about Wikipedia is that you can, what just happened? See, this is the problem. Things suddenly go wrong and then this is sort by books. There you go. Let us copy the whole thing. Let's just limit ourselves to this much. I'm going to simply stick this in a file. Where you want to see this layer now, not necessarily. It's actually a tab separated file. And quickly check if it is importable in pandas or something. Actually, I did not expect this to work so well, but it does. Anyway, now let's alright, there you go. So my DF is table of instance arrow this code. Very good. Yes. Except it's not a collaborative notebook. Right? I will check the finished notebook later, and please feel free to follow along. Those of you who are following along, if you need me to wait, please ask me to. Yeah. And like I said earlier, do feel free to share, laptops with your neighbors. Right? Oh, sorry, I just understood what you meant. Can you share the data? Oh, there you go. When you have located the elections.tsp file, let me know. Oh. Has anybody found their way back to the elections.tsp file? Great. Okay. Oh, by the way, you don't have to do this on collab or anything at all. Feel free to use your local live Michael or so on. I'm just doing it on collab so that it's shareable later very easy. Oh, sorry. Does anybody still need to access the QR code? I'll leave it open, of course. But is there somebody who's having trouble getting the data? Or should we continue?
Yeah.
Okay. Anybody who wants me to? Okay. All right. So this is how we would see the data. Is this visible? Right. So party, the absolute number of votes, percentage of votes, and the seats they hold. Those are our columns, right? What's the first thing you do when you have a data set like this? How that is incident. That is procedural. Okay? What would you like to do with this first? You want to do something in order to do that in the field. Get a summary, right? What sort of summary do you think this is going to be? It's an Indian Lok Sabha elections data set. It's clearly 545 seats. Everybody knows that. Percentage division of each party, which is present in a column to us, yes. For which we would need historical data. Sadly, in India, it doesn't work. So, who's heard of Nate Silver? There's a person called Nate Silver. Who's heard of him? Okay. So, Nate Silver is known for consistently predicting every single state in the US elections, the outcome of whether the Republican will or Democrat will. And many people have been trying that very hard in India as well. Trying to predict, if not every Lok Sabha seat, at least every state. But it doesn't work because typically in the US elections are very, very specific in the sense that people ask for votes based on very specific issues. So it's either employment or education. Of course, whether that actually pans out or not is a different story, but the entire political discourse is centered around these fields. Right? And it changes from state to state. Of course, it's not like there is no balance in politics or there is no nationalism or anything like that. It is very much there, like as Tom showed us. But even the headline would be something like "Make America Great Again," but it has to dial down jobs, right? In India, it's getting extremely specific for it.
So I'm not entirely sure how the elections work.
Yeah.
But doesn't he have a way better chance of predicting us 50-50?
Towards 50-50.
So they have a two-party system, right?
Yeah. Precisely. It's very clear.
Yeah.
Data there is very clear.
There are a lot of parties, there are a lot of people fighting for
absolutely far less this. The system is far less. Yes. Alright, so yes, now we come to the these are just summary columns. So 910 million people turned out only. That's a pretty small number. Total votes, out of which somewhere invalid and so on. And then we get that. So what we have to do is simply take everything from number 4 onwards. So what you do is let's see if that works fine. This is short. Yeah. There it is. So, just by looking at the top few rows, you notice something really weird, and I'm not sure if. Okay, now. Ouch! I lost all my data. Okay, let's redo this. There. How do you? So I accidentally took only the 4th to the 9th row and dropped it. Okay, so some things are pretty peculiar here. Now, obviously, everybody knows what a landslide 2019 was. But what's the next most surprising thing? The landslide here is not surprising, right? What's the next most surprising thing that you can tell based on just this? If you remember, this data that we took was sorted by number of votes, right? I clicked on votes before I did the copy paste. So what's surprising about this? Look at the difference between that second and the third. I really wouldn't have guessed that TMC is actually the third biggest winner of the elections. I would have thought it's probably some party in BSP, JDU or something like that. Maybe something in the Hindi belt or whatever. Right? Although बहुjan Samaj Party does form very close. So here is our first visualization problems. We, again, clearly, by simply looking at tables, things like these are not apparent. How would we visualize this? So it's reasonable to assume that these three columns are fairly connected to each other. They should have a very high correlation, right? So what we say about one should have hopefully, let's see. So what's the best way to visualize this? We know that there is a surprise. We found the first interesting thing. Okay. Sorry? Very good. Let's take a look. Which column would you like to plot? Seeds is small numbers. Let's pick something a little readable. Okay. Seeds. Percentage is slightly better because seeds could change, right? And let's assume that we're doing this for 2024, maybe 2029. around 3 as many code as possible, right? Percentage is slightly better, right? Yes. Is it visible better now? Can I just do this? Is this being recorded?
Yeah.
Alright, so let's take a look at what a pie chart can do for us. So let me just pick out the relevant columns first. I'll do that by saying that I only want the party and I want the percentage, right? And then what I want to do is I want to use the party as the index column. So do I have X properly? I do, right? Okay. Let's not pay too much attention to the code itself. This is the sort of thing you could do in Excel, Cbot, Matplotlib, whatever it is. Just doing whatever is least time for you, right? Let's take a look. What do I do?
Really long tail.
Precise. Anywhere where you have data related to politics, economics, or in any case where somebody has to make a choice about something, could be consumer data, right? Could be surveys. Wherever somebody, it could be a citizen, it could be a customer, somebody who's sort of opining or somebody who is making a choice in terms of any sort of choice, wherever human choice is involved, and if the number of choices people have is large, we see what is known as the long tail graph, right? Which means that most people will opt for the top 2-3 options that they have, and there is an infinitely long tail which you will never see. This becomes a problem with things like recommendation systems and also what you see on the Amazon page is something like only the most popular things people will never choose to buy, right? But if you really end up in some weird corner of Amazon, you might find things that you always wanted to buy but forgot and now they're available for a cheaper price. You could, do this enough for good and all that, right? So what's the problem with this long tail, which means that too many things to show for someone. Do we care about it? So beyond a particular percentage, I don't care about which party won what percentage, right? So how do we fix this? Yes, let's say we have a threshold at. Here's the interesting part. Get down to 2% by just the 4th or 5th row, right? Down to 2.7%. Right. So what should be a threshold? It can't be 1%, it can't be 0.5%. Again, long tail. It's a classic Pareto massively negative exponential kind of curve. And a very routine thing in economics and markets and things like that. So again, this is giving me absolutely no more information than looking at TF tells me BJP won. Congress came second. Trinamool Congress, why is still surprising? It's not telling me instant. Right? Bahujan Samaj Party, okay, independent. That is actually another surprise. Right? The 5th highest category was independent candidates, which is weird. I would have expected, I don't know, even Aam Aadmi Party to show up. Definitely some of the UP Bihar-based parties or something in the south, the DUP and all of that. I would have expected that. Okay, YSR, Congress is there, and so on, right? Another problem is I could be reading this. I don't know once the labels start intersecting with each other. I don't know which sector of the pie they are referring to. And then all of this is like complete nonsense anyway. It's just a mistake. So, okay, yes, we have a threshold. Let's say X%. So that X is. What do we do with the parties that have less than X% votes? We could choose not to show them, but that would be withholding of data. We're not telling people because the pie has to add up to 100%. Right? We just pick them and call them others. Right? That's what we do. Right? Alright, let's see how to do that. Would be let's take a look at the tail. So, oh boy, let's just fix it at 1%. Then let's try. Let's say my capital T for threshold is 0.1 or we'll just say 1. Okay. Let's say my X is now exactly this, except where if percentage is greater than or equal to T, so that I can keep changing the threshold. Now again, I've dropped off some rows. What I can do is X equal to, I want to add the rest of the rows back, right? So let's say something like new scores is equal to the inverse part of it. So it's exactly this, except now I flip the sign, right? Let's take a look at how many more scores, or it doesn't matter, right? I can just basically say, actually, it doesn't matter. I care about all this. I will have everything in my X until a certain point, and everything below I want to be others. So all I have to do is just append a row to X, which contains the sum of let me just do X dot A, so I get to figure out what the bottom is. It's 21, so I'll get basically 22 sectors with my Y now. Basically, X dot log of 22 is something like this. pt dot series such that party is others. And what's the percentage here? -100 what of the sum of that, or since we have this variable here anyway, it's the sum of those, right? Does that make sense? And then let's stick this over here and try to do everything again. Oops. Something went wrong. Oh, my X was, I did not set the index part properly, but I did do this here. So let me just copy this, say that. Sorry. Sure, no problem. So anyway, do not worry too much about simply catching up with the code. Okay, I made a mistake here. It's now my X is all gone. So let me do this again. I can make my X again, and this time what I'm going to do is, instead of putting it in place, I'm just going to say plot percent. Let me just put it over here. Slightly better, right? Not as bad as that. Okay, see, yeah, this is the original one. Slightly better, but what does this mean? Still need to raise the threshold maybe a bit, right? Let's try that. So what I'm going to do is keep it at 2%. Let's see what happens. Now I have 13 here, so I'm going to put 14 here. Okay, a lot better. But here's again, here's the problem. Like, others is suddenly becoming big, right? It doesn't really matter, the fact. The problem isn't that others is becoming big, but the pie chart makes it so obvious that it looks a little distracting. In general, pie charts are very bad, especially if you have more than 5 or 6 sectors. This, no matter, I could keep on increasing and decreasing the threshold, but I'll more or less keep running into these problems. So what's a better? Start is a better way, yes.
If you separate the maybe only show the others, and maybe you can do like the parties which are the least number of scores or something.
Sorry, I couldn't.
Here the others is very much visible. If we do a second graph that only shows others, and then we do a filter on the list of the least number of scores or.
Got it. But then, instead of one chart, we have one chart for non-members and the other chart for others. It's basically the same thing, right? Yeah. So, yeah, I mean, you could do that if you had the space to accommodate that. But let's say one chart. And again, remember that our point was to be a little less surprised. So let's try building a bar chart. I'm just going to take the percentage column, and this time I do a plot time equal to. So yeah, in general, pie charts aren't great; they're generally bad. But what is worse is the pie charts. And people can go mad with this sort of stuff, because creating pie charts and adding extra effects sometimes is so easy these days. And let me see if I can find a good example of why they are bad. Look at that. What is this? Sorry? If my data wasn't very clearly, this yellow part is the BJP, but wait, how much is this other? This could be Congress, I don't know, but first of all, this red, so I'm inclined to think of the left and right party, but that's not good. But like, look at this. There's a very interesting course in the University of Washington called College Course. So, you can take this course for academic credit by the some of other universities. And there's a nice book also which you can buy. But there is some very interesting case studies they have on how data visualization goes wrong. Let me see if there is. So the principle of proportional length is something that comes from somebody called Edward Carpenter. So the amount of ink present in your visualization has to be proportional not to your data but to the information you want to convey. Extra ink means extra information, which means people have to spend more of their vision processing that extra ink. Right? Which doesn't add anything. Now, for example, here this chart is really bad, but there is an unnecessary gradient in the chart. Doesn't convey any extra information. But it's still there, and to direct this for too long, you'll probably get distracted by it and feel like, okay, does the gradient really tell me something? It doesn't. Right? So why, and again, it's a purely optical illusion, but the larger this bar is, the more the gradient becomes prominent. Right? Here it's not so prominent, and therefore, this bar looks a little, at least on my screen, it looks a little darker than the others. So this extra ink for movies. Which is also why sometimes I see that when people do bar charts, they want every bar with a different color. Just because they want more color. So, it's like, when people see colors, the reaction is to associate darker colors with higher values and lighter with lower values, or the other way around. Right? And that's just extra unnecessary information. So, look at this. What do you think is wrong with this? Well, that's okay. And it could be. That's fine. It's numerically accurate. No problem. This idea is a problem. For example, they have put it right where it doesn't belong. Look at the way Twilight is written, the Twilight Saga. Look at the way Harry Potter is written. They are trying to be creative, but this is not the place to do that. Right? The big problem with this is they have added a constant offset to the bars, which makes no sense. So, for example, if I simply look at this, I would say that the Diary of Anne Frank, which is to the extreme right, is almost the same sales as the Da Vinci Code. But look at the numbers. Da Vinci Code sold 57 million copies. The Diary of Anne Frank only sold 27 million copies, less than half. But they look identical almost. Right? That 30 million worth of difference is lost. Of course, not that if you were to still take it away, you would still sort of not see the gap much because the Bible holds so really. So this is when you start putting things on a logarithms instead of values. So again, violates the principle of proportional. This, for example, I think there's a gradient of it. Right? Absolutely. And what is worse is that it overlaps with the grid lines. The grid lines are provided with the timelines that you see so that you can put the point values on x-axis. Now, if I want to think about what is the tax rate in 2015, okay, it's somewhere below what? I don't know. So I have to look at the line there, then try and guess what part. So it seems like it's 32. That's still too much eye-movement, too much, cognitive processing that should not have to be done. If the grid lines were on top of this, it could have been perfectly fine. Plus, whenever the area is filled, you start thinking about integral values, area to the curve, why it doesn't matter here, right? Unless you are thinking about things like between 99 and 2001, what is the total tax? Which you then multiply by the actual number of people pay tax in the amount where you get the some government collected. It's a simple time series, it would have been a simple time, right? So, anyway, I think I was looking for, this is also a bad example of a pie chart. It's actually not a pie chart, but somebody got carried away. There was one very 3D graphs are bad. 3D graphs are just really simple bad. What do you get to systolic, diastolic, and also the vertical axis? No way to. Okay, now I have to read the long caption. Okay. Look at that. Not required at all. This would have been just a flat bar chart. Wouldn't have hurt anyone. Right? Now you see the Google bar, it looks, because of the 3D effect, it looks disproportionately larger. It may be large, no doubt. But it looks larger than it actually is in comparison to mine. Right? And there it is, finally a 3D bar chart. Android market share is 49.64%. Does that result look like it's less than half or around half of the whole thing? It looks larger than half because of the 3D effect. Right? So because you add that extra third axis over there, this portion.
So it was supposed to be 49.6, that's equal half, say 50%.
It looks like he's eating up the whole thing. Right? This is why 3D pie charts are bad. In general, pie charts are bad. Do not do pie charts. Okay, please. Absolutely. Yes. Yeah. Which is where you can't stick to a linear scale. You go over the bottom piece. Basically, what it does is it makes smaller numbers relatively larger and larger numbers relatively small. just for the sake of comparison, but you have to tell people that this is not cost. So, see that things are not only larger or smaller, they are larger and smaller by an order of magnitude entire. Normalizing is a good alternative as well. But you either normalize or you do a loss, whichever is better. But normalizing again, you lose the absolute differences, but you get proportionality. So that's good. That's still good. However, simply normalizing again wouldn't solve the outlier. Because let's say this particular thing, if you wanted to compare BJP versus independence, right? Independence is the third, fourth graph. Even if you normalize the y-axis on a 0.35 million or whatever it is, percent, sorry, it's percent, it's not the number of cents or votes. So, if you were to normalize it into 0 and 1 scale, the relative length would stay exactly the same. With log, it won't be that. And let's take a look at that. Now, this is clearly wrong because we did not have. I have modified the integrity far more. So, okay. So, Panda series already have an index. So, what I can do is take the party column. There. It's really bad. Yeah, exactly. I can see everybody before this. So, what do you do with this? What's the better way to fix this problem? No, there is a far simpler solution. Instead of horizontal bar chart, right? All I have to do is instead of bar, do a bar edge. Now I get a wider graph instead of a problem. May still be a problem though. Okay, fine. So I can actually do a little hack and say PLT.type layout, maybe, yes. That essentially ensures that things won't be too much. Slightly better. One way, if I'm good recipe, at least in my project, to avoid all of these nonsense is to add what is known as a style sheet. I can use plt.style.use 538 is the publication of that it's a workspot, and they have a micro style sheet. It's pretty good. Oops, sorry. And then let's see what this looks like. Let's go 538 style sheet. Oh, okay. That is a lesson. Easy plot is fairly close to 34. This is slightly. Did you notice the difference? Ignore the 538 part, I was clearly excited. But between the first one and this one, do you notice the slight difference? Oh my god. This isn't visible on the screen at all. What it has done is, let me see if I can open videos in a new direction. Okay, greys are not very visible there, but what I'm seeing on my screen is that all over this area, there is a nice grey grid, which was earlier completely absent in that. There are default horizontal and vertical guidelines, so I know exactly who crosses the 10% threshold. There's a line here, there's a nice thin greyish line, and there's a nice thin greyish line at 20. In fact, those of you who are following up with the GG block size. So these style sheets, what they do is that they add some basic sanity by default. So always recommended to use one instead of using the default one. Okay? And they'll take care of the fonts and everything. But again, you see that this is messing up again. Right? plt.style.use. And you can look at all of the available Yeah. So there are a ton of style sheets available. There is one for XKCD also. So you can get your chart reference like XKCD comics, the classic comic font and things like that. You can do pretty easy. Now, one of the things that is wrong with this again is that the labels are open. Let's see what we can do. What would be the easiest way to fix the overlap? Increase the height, right? Straight away. So for that, what we could do is I'm going to create subplots which are essentially grid plots, but I'm going to create only a grid with one row and one column. It's just easy. And I'm going to pass it a parameter called figure size, fixed size. And I think it's height by width. If I'm not, I'll find out in the day. So let's just say I want 12 by 8 or something. And we'll pass the same axis with the oops. We did not actually type on the axis. You see this? Oh, I made it a little too large, but that's fine. But the data warrants it in certain sense. However, I could afford to reduce the width of it. So let me see if I can make this maybe 6 by 8. Much easier, right? I still have to scroll, but that's because this. There you go. Now we don't have to scroll. So, right? And of course, it matters whether you want your highest values at the bottom or not. Most often, whatever metric you care about, you hold it at the top. So all I need to do is sort values, and I will put ascending equals something like sort values by percent of sort. I didn't tell you what to sort. That is strange. So, I am seeing that. Or was it actually plotting from bottom up in the first place? So yeah, it was the bar chart that was actually doing some extra application of brains for movies. This is better. Right? So we have a bar chart. We know exactly which party crossed the 10% together. This is look at the other thing. Now the ticks on the y-axis are listed because we shrunk the party, right? Okay. BJP, Congress, TMC, BSP, Independent, YSR. This is where some of the others show up. But what is interesting is that so many different. Okay. Okay. And again, now that you look at the bar chart, is there any point in even showing any of these after JDS or whatever? There's no point, right? Those are the ones that you would club it, right? And that you can take that back to the pie chart also. So that's where we draw the threshold. The pie, unfortunately, again, if you look at it this way, they all look pretty much the same size to me. It's difficult to figure out where to put your threshold. But when I have a bar, it's very clear where I want to put my threshold. Right? Wherever the red ink disappears, that's where I put my threshold. And that can lead to potentially better pie charts as well. Because now I know what to put my threshold. So these are some ways of seeing which parties got the most percentage of votes. You see what else? What else could we do with this? Let's see all of that over here and take a look at our raw data again. Unfortunately, this data set doesn't tell us anything about modules. That would have been used. But of course, like, mergers usually happen after the results are out as well. So we have votes, percentages, seats, and so on. What are the other interesting questions we could ask from this data?
I'm asking them why can you speak it in number? So that was can you. How many votes are required for getting one seat?
How many votes are required for getting one seat? Okay. So let's take a look. I think these are all participant management policy. No, they have it. Okay, so we have parties who did not. Of course, we have parties who did the seats. But you see that. Let's look at the last 10. There are parties who have had higher percentage of votes, but lower seats or zero seats. So you see, this is sorted by number of votes. Why would this happen? Exactly, depends on where you are, right? So what's a good question? What's an easy region to pick, right? So what we want to figure out is which is an easy seat to win. Where overall I don't care if I get less votes, but I'll win at least one seat, something like that. How would we find that given that we have two columns for votes and seats? Why would they be overlapping? We saw it here, the x-axis, it actually has no problem making the x-axis numerical. No, it is set on x. The df index doesn't matter. Basically, we're just giving it two arrays and asking it to plot two students. It will, but the thing is, we have not encoded the votes as numbers. The comma in between fooled it into thinking that these are strings, these are labels, and whenever Packlogger will find labels, it knows that these are categories, these are not scales, these are not comparable numbers. So let's fix that first. I'm going to do something like df of votes is df, is it capital V votes? Yes, it is. And we say df of votes, what is here replace. When we find a comma, replace it with a string and then convert the whole thing to an integer. If there is a problem, this cell will crash. It did not. And now, when I do this again, there you go. It's making it. But now the same problem exists on the y-axis.
There are things like dash and zero and whatnot.
It's clearly not in sorted order. It's not a y-axis at all. It's just something, right? Let's take a look. What stops me from representing seats as a number? Can I do an as type of int here as well? Clearly not, because I know for a fact that there is a hyphen somewhere. Let's find the rows where there is a hyphen. df of seats equal to hyphen. Again, there will be all those different types of dashes we have, and I hope I get the right one. Just the standard one. Oops, yeah. There's nothing. So clearly, it's something is off. How do I type? Good point. Yes, you could straight away copy it from the close back and paste it back here. Slightly wider, right? Is this what is called an end dash or an end dash or something?
There's two. There's an end dash and an end dash.
None of the above. It's a party. It's not a party, but it's very much a candidate, right? Now here's the thing. What do we do with this? It's 1.06%. That's not a small figure, given the kind of data we've seen. Can we simply say 0 6? For now, yeah, why not, right? So what I'm going to do is df.log of 21 seats is 0. right? That's done. And then I want to try and see if now I can convert everything into an integer, and I can, right? So let me assign the seeds back to the original data frame. And now what I'm going to do is, this graph again is meaningless because the y-axis is all the same, right? It should be something meaningful. Not bad. Right? As nodes grow, seeds clear. It's one comment in this. But what's the problem with this? Oh, that is there, yes. And think about the interpretation of this. No, it's not about the art or the format of the chart. Think about the interpretation of this line graph. Yes, when we say linear, we are almost always pulled into thinking about weight or variance. True. Votes, seats do go in proportion to votes. But is this really meaningful? Actually, do seats actually grow in proportion to votes? They don't, because once you pass the majority, who cares how much votes you get? Yes, true. Which is why here we are enforcing correlation. When you want to find correlation where you don't know whether there is any correlation or not, avoid line graphs. Because when you look at a line graph, it will always say, yes, pakka there is correlation. Because the thing is, this line doesn't exist. It's not like I have a formula for that. I did not ask Matplotlib to plot it as a scatter plot. That's why it was supposed to draw that line, because I didn't tell it to. But the thing is that this straight line doesn't exist. There are many points here that don't exist. If I'm not wrong, it's like there's a point here, there's a point here. This is BJP, this is Congress. Yeah, clearly 300 odd seats, BJP 50 odd seats, 52 seats, I think Congress, right? So this makes sense. But what this graph moves us into thinking is that if there was some magical party in between which had exactly 150 million votes, they would get 100 and whatever number of seats. That won't happen. It doesn't exist anymore, right? So what we do is we use a scatter. To outlast here, is this enough to figure out the problem that you wanted to solve earlier, which are the easy places, or which are the parties that got it easy? Those were your direct competitor, then we would have. So this doesn't tell us anything, because most of the data is concentrated here, right? So what do? I can zoom, I can magnify myself to that area. So what I can do is PLB.x limits. Okay. No, that's okay, because I know what Congress and BJP is done, so that's not my interest anyway. Right? So now it's obvious, it's the largest two parties. I know what they've been up to, what sort of performance they've had. That is out of the question now. In fact, I know the top 20 because we've seen the bar chart. Here we want to explicitly focus on the lower end of the data. So let's change the limits of our graph. So x-axis, I want something like 0 to 0.2 maybe, or let's say to 5. And y-axis, I want to from y to be 0 to 30. Let's see what that is. Okay, that's interesting. Did I make a mistake somewhere? Oh, it was 0 to 0.5. Let's take a slightly larger box. It's basically telling me that absolutely nothing to do with this. Yes, very good point. It's of the order of 10 to the power 8 or something, right? So my excellent between 0 and 1, obviously nobody got between 0 and 1 vote, right? Some parties probably did. But again, when my axes were off by, I started confusing things. Okay, let me see what the scales exactly are. These are definitely in the hundreds, no doubt there. So, and this is, let's say, yeah. So my excellent has to be something like 0.51E8, right? Something like that. So now I can say 0.3 maybe, right? And here it's the same, 0 to 50. We're getting closer. Except my axes are getting a little cut off, so let me add a little negative scale there too. Just like 0. Minus 0.1. These are all very high set. Sorry, again, this 2 has to be 188, right? Only then slightly reduced. So, you see again, there is a straightforward, there is a good trend theory, right? But if you want to say fit a linear regression to this, what would you like? It would probably something like this. Which side of that line should I look at in order to find seats that don't cost too much? Rows, right? So, yes, more seats are on the y-axis, the upper side.
This was my trajectory. So this was the linear. What's that on the upper side? Seats that are higher or relatively lower portion, right?
So let's take a look. Is this something like that? Maybe. So if I want to use something like Plotly Express or something to label these, I think I can. So I don't want to install it, but it takes a data frame which is here and x equal to books or equal to seats. Is that all? It does, right? And then can I do same x limits, same y limits. But anyway, the thing is that even if I were to do this, annotating each plot by running through the data frame. So let's just drop this idea for now. So here's the simple way of finding out these outliers. Actually fit the linear regression, see whatever's on the upper side of it, see whatever's on the lower side. Those are the existing things I have. Right? Now, is our interpretation correct? What's our if we were to simply look at BJP and Congress, Congress is squarely on the lower side of it, BJP either on the line or on the side. Why do I say BJP is on the line? Because it's so much of an outlier that it's practically dictating the slope of the curve, right? So BJP obviously doesn't make sense. But if I were to simply drop from 0 here to BJP, whatever's lower is performing really bad, right? And those are not what we do. That's why we look at whatever's above there. Now the only places where that can be found is this tiny region over there. Those are the parties who, for relatively less votes, got some seats. Okay? To figure out where they are, contesting the elections and go in competition. That's something that you would tell your parents. There you go. So, we have about 15 more minutes. What else could be? Which one? It's not showing correlation at all, in fact. It's just a suggestion as to whether there is correlation at all or not. And here I would say, of course, there isn't correlation because there are these two parties that are such massive outliers. And we knew that in a sense because if you simply look at the percentage, not to mention, of course, the drop between the first and the second party is massive. No doubt. First party scored almost twice of what the second party scored. But the third one, look at how large that drop is. So these two are clearly outliers. And after that, you see the numbers start becoming a little reasonable. They start falling in a reasonable way. Right? So in order to, and obviously when you have outliers like this, correlation inherently is a linear measure. Right? So correlation has already gone for a toss. You drop them and then you see what happens. That's where you actually get a good idea. Outliers will always hurt that sort of thing.
If we just look at the numbers like 229 million versus 280, so it was just 0.7 or 0.6 times the number of 0.6 million votes was all they required to get a seat, right? INC would have required 15 votes to get one seat.
Yeah. That interpretation we can't get from this. Yes, true. In which case, you actually do a more non-linear regression and see if that works. And it could. And of course, then you would have to, you can't consider the names of the parties as features, of course, but that might work. You sure that's something.
Yeah, I was saying, can we find how many parties got just boost in Nota?
That's a good question. Yes. And we have DF of party dot SQL dot okay, they got these many number of votes. So what I want to do is DF such that DF of votes is less than T. There are quite a few. And they did this. One of the Lok Jan Shakti Party is 60. I think they're already sorted by board. Yeah, there are the parties. One good way of actually doing this sort of visualization is look at the bar chart again and add some sort of but no, our chart is actually trimmed anyway for the top 20 or something. You could add, like for example, here. We know that our threshold is so and so, so I can go ahead and say here, for example, I can draw a vertical line there. Experience at T from 0 to 0. Then let's say I wanted a black dotted line or something like that. So what do you say? Color is a separate thing and line styling is a separate thing. It's too thick, but you see that there are all these, again, let me go ahead and apply the limits. Yeah, tons of people do this thing. Lots of rules exist which are less than overall Nota.
So that Nota is a sum across the country?
Is sum across the country too.
Some parties, state only versus national Nota.
Correct, yeah. So it's an unfair comparison, sure. But again, the idea here is that if you want to establish these thresholds in your scatter plots or any type of that, you can draw specific lines there. Okay, the line is slightly bigger now. I can adjust the line with the line style and cover of the line and so on. Alright, I guess we are almost out of time. We do have 10 minutes, so I'll be happy to take questions, thoughts, comments. Yes, please go on in any order.
Do you have some kind of rule of thumb or something like, when I have no idea what kind of chart to pick, this is probably a good idea that this kind of chart is probably
Yeah. It's driven by what you want to do, what questions you have of the data. You are simply exploring, there are things like if it's a number that you're measuring, the columns, the very first thing I want to do is, a series of numbers is find its distribution. What is the minimum, maximum, average, blah, blah, blah. So the first thing I want to do is plot and history. Right? If it's large enough, if it's just 5 values, I just divide them by and see what happens. Then if it's something that grows with time, I will pick a line chart. Or if it's something that grows as another variable grows or decreases, it's a line chart. If I don't know its relation to another variable, it's a scatter problem. Right? If it's things like group data where categories are involved, and we have things like maps and things like that. Sometimes it's easier in the sense that if I had state data associated with this, obviously I would consider this map. Right? Get the sheet files shut probably here. Yeah, so this is a shape file which lets me plot an India map for this. And then I can choose what color to put in each state, which could just be how much a particular party wanted, the balance of power and that state and so on. So depends on the domain, depends on the nature of your feature, depends on the question you're asking. Yes, please.
So my question would be, what would be the use case scenarios for box plots?
Okay.
Because it's kind of confusing when we see those box plots. It's very hard to understand and what's the line between those.
Let me figure out. There was this very interesting course we did a while ago on data visualization design, and we had some box plots there for sure. Let me pull up some examples. From distribution. So the key idea is variances essentially for box plots. You want to compare how much one variable spreads relative to the spread of another. That's when you would use something like a box plot. I can't seem to find a good example, but at least not in this course that we had. But I was assuming somebody must have, because what happens is that there are typically people who are very good at doing one type of plot. So in any assignment, that's the plot they pick, whether it actually meets the purpose or not. So for example, this particular person, whoever they are just great at doing line charts. This doesn't tell you anything, right? The x-axis is weight and pounds of car and the y-axis is miles per hour. Okay. It generally decreases. Clear, like so noisy. What does that noise mean? So bad example, bad usage for a line chart as such. Or you could have at least done a few things better. Isn't there a single box plot here? Because I guess we're talking about variances in this.
Can we share this GitHub link as well? Is it open?
Okay, this isn't being by the way. Okay, this is a step up.
No, I'm asking.
Yeah, we can share this. Do go to github.com BSCF and IITM data visualization design. Just for data visualization design in the BSc IITM. The entire purpose of that course is to look at data visualizations, critique them, improve them, make it work. Look at the issues in this repository. There will be a lot of wealth of data. So, finally, now what they have is what they're trying to do here. Origin is essentially where there are three things. This is basically called the MPG or empty cars data set. There are a bunch of cars and there are various attributes of those cars in the data. One of those attributes is origin. Like where did the car come from? Where did you buy the car from? There are three vendors, right? And on the y-axis they have miles per gallon, right? So what does this box plot tell you? It tells me that in the most basic terms, if I bought from the third vendor, I'll get average higher miles per gallon. But there are outliers there, right? So, for example, their maximum is
About the same as
not their maximum, but their maximum is way higher than above. Their minimum is also way higher than the others, right? So, it's a reliable way. That's what it is. Even the average is outside the other ones. If you have to pick between 1 and 2, you see that they have a lot of overlap in games.
minimum for 1 is far away from the minimum of 2. But the maximum aren't that far. So 2 is better. Because I don't want to be stuck in this area if it can be easily avoided.
Right? So that's the interpretation of a box plot. When you're comparing variances of numbers across the system. There was another question, yes. Sure.
The line that's in the box.
Sorry?
The line that's in the box.
That's the mean. Yeah.
And those these are one standard deviation given.
So small, that's also.
Actually, yes. I don't completely recollect what swarm plots are. Let's see if we can find them. Oh, I see. Oh. It's very simple. It's essentially talking about the spread of data across multiple categories. Yes. However, now that I think of this, if I had more time to explore, I would build a swarm plot because it shows me individual data points. That one gives me an aggregate picture. So I can see that these 2 points here are clearly outliers. In this case, where that thing go? Did I override it? Anyway, in that case, there were outliers too. These are outliers too, but here it's the statistics that is telling me that it's not. I do the maths and I figure out which points are more than second or third standard deviation away from the mean. That's automatically called outlier. Whereas in the swarm plot, I have to sort of use my own imagination. So those are the pros and cons. This could very well be more suitable. Yes.
You know that 3D graphs were quite useful in most cases. So is there any case where 3D graphs are actually useful?
Yeah.
It's why does it exist in the first place? Yeah,
I'll tell you why. Basically what happened is there was a time when Excel was pretty much the game. Right. And they had no idea what to do. So some poor marketing executive was doing, let's actually do it. Do we have anything to release this year? We have 3D. 3D visualization actually could be efficient, but so for example, I may want to figure out what is the correlation between 3 variables and so on. But looking around at those you have points in 3D scattering around, it's really difficult to see. I'd rather use maths. And I'd actually compute correlation and look at that numerical figure and see if that makes more sense. Alright, I'll be around. Thank you very much.
Jaidev, we have 10 minutes, so if anyone wants to ask,
Yeah, we will have 10 minutes. That's great.
anyone? Till then, you can share the class.
Yes, let me see if I can make this popular. Like that. I did something. There you go. How can we use? What? Utilization? Visualization and deep learning. Okay. One of the very first attempts at doing that came from a fellow called Chris Cola. So let me see if I can find his work. There you go. He was the first person, by the way, what he did was actually very straightforward, but he was one of the first persons to figure out that once a network is trained, you can simply tear it apart, look at certain layers and visualize them. And when that happens, you'll see what the network is actually learning. So if you take a relatively straightforward CNN, let's say BGG16 or something like that, it's straightforward in the sense that it's yes, it is. It might be. They do. You can use it. Yeah. How do you think it does it? People do. So, and the companies are going to. So, what they do is, if you look at some of the deeper neurons in any fully trained network, they start looking like objects. That's because they have become trained to respond to certain types of objects. So let's say I want to distinguish between 20 classes, 20 species of birds, let's say. I have 20 neurons in my output here. And if I look at the weights associated with each of those neurons, and I try to do a visualization of the weights, it might end up looking like one of the bird species, or at least an average of all the bird species that have been presented today. If you look at some of the earlier layers, then they represent some very elementary shapes, because straight lines, curves, and things like that. And the deeper it gets, it keeps on applying more and more detail until it becomes this full form also.
Jaidev, we are out of time.
Alright.
So if anyone
very fast 10 minutes.
Yeah, we had some new information there.
No problem, I'll be around. Do it.
Yeah, you can talk to Jaidev, he'll be around, and the lunch is open for this room, so you can go and get your lunch right now. Thanks everyone. Thanks Jaidev. Can I have a round of applause for Jaidev?